Okay, so welcome to lesson 5.12, finding the equation of a line, part 2. So by the end of this lesson, we should be able to find the equation of parallel, perpendicular, vertical, and horizontal lines. So as a quick little warm-up, we're just going to review what some of these are. So parallel lines first. Do parallel lines intersect? No. That's what makes them parallel. The slopes of parallel lines are the same. The symbol for parallel lines is that. So if we're given a line, they want to know what the slope of a parallel line would be here to this one. So slope parallel would be, again, it has to be the same slope. So -3/4. For this one, the parallel slope, well, if we pictured in our head moving that 4x over, it would become a -4x, so this would be, our slope would be -4. Okay? For this one, we'd have to rearrange, so -2y equals -7x plus 3, divide everything by 2, and we'd get 7/2x minus 3/2. So our parallel slope would be 7/2. Okay, perpendicular lines. Perpendicular lines intersect and form what kind of special angle? It's that 90-degree angle. The slopes of parallel lines are negative reciprocals. And the symbol for perpendicular lines is that. So now we want a slope of a perpendicular line here. So slope perpendicular, again, flip your fraction and then change its sign. So it was negative, now it's positive. Over here, we're going to have to rearrange these. So we've got -3y equals -9x minus 6. Divide everything by -3 in my head. This gives me a +3 and a +2. So my perpendicular slope, well, if my slope was 3, now I'm going to need a 1/3 and make it negative. And then for this one over here, again, we are going to have to rearrange. So -7 plus 3, divide everything by 2. So we've got -7/2. So my perpendicular slope, flip my fraction, is 2/7. It was negative, now it's positive. Okay. So now that we hopefully remember a little bit about parallel perpendicular lines and how to find their slopes, now let's try to find the equation of these parallel and perpendicular lines. So for our first example, we want to find the equation of a line that's parallel to this y equals -1/3 x minus 2, and it passes through this point 3, 1. And we're going to confirm our answer by sketching our line on the grid provided. So the one that they sketched here is this y equals 1/3 x minus 2. Okay, so first thing we want to do is find the slope. So we have this equation here, and it said that it's parallel. So we want a parallel slope to this one, so it has to be the same. Next, right, we need to find our y-intercept. So we also have this point 3, 1. So we're going to sub that point into our y equals mx plus b. So our m is -1/3 x, and we want to sub in our point. So y is 1, and x is 3. Well, these 3's cancel out, and we're left with -1. Move it over, 1 plus 1 is b, so b is 2. And then last, we want to write our equation, and I'm just going to short form equation. So we've got y equals, my slope was -1/3, and then an x, and b was 2. And they want us to confirm our answer by sketching our line. So if our y-intercept is 2, and then our slope is -1/3. So we're going to go down 1, right 3, down 1, right 3, and draw our line. I can get my ruler. Okay, So we can see our lines are parallel. This is my 1/3 x plus 2. Okay. So next, we want to determine the equation, of a line that's parallel to this and passes through the point 10, 5. Okay. So first we want to find our slope. So we are given this equation, and we can rearrange it into y equals mx plus b form, and that'll tell us our slope. So 5y equals negative 3x plus 9. Divide everything by 5. Y equals negative 3 over 5x plus 9 over 5. So therefore my slope is negative 3 over 5. And that's my parallel slope that I want, right? Because it said parallel. So next we need to find our y-intercept. And we have this point 10, 5 that we can plug in. So we know we have y equals negative 3 over 5x plus b. Now let's plug in our point. So y is 5, and x is 10. So let's simplify this. 5 goes into 10 2 times, so negative 3 times 2 is 6. Move that 6 over, it becomes a positive, so our y-intercept is 11. So now we just need to write our equation. So y equals negative 3 over 5x plus 11. Okay, so let's try another. We want to find the equation of a line that's parallel to this one and has the same x-intercept as this one. Okay. So first, again, let's find our slope, right? We know we have a line that's parallel to this. This is an easy one. Let's just rearrange to y equals mx plus b. Oh, wow, I could do that even easier. I don't need to move the other two. Let's just move y. Right? So y equals 3x plus 5. So my parallel slope is 3. So next we need to find the x-intercept of this line. And in doing so, it will actually give us a point on our line. So if we want to find the x-intercept, we know we have to make y equals 0. So we've got 2x minus 3 times 0 equals 12. So 2x equals 12, divide both sides by 2, x is 6. So therefore, our x-intercept is 6, 0. So now we have a slope and we have an x-intercept, so we can find the y-intercept. So we're going to plug in our slope, and then we can plug in our point. So y is 0 and x is 6. So we've got 18 plus b here, so move it over. We've got negative 18 equals b, right? And then last, we want to write our equation. So y equals, my slope was 3, don't forget your x, and then my y-intercept is negative 18. Okay, so we've got a few more examples with these. A line is a direct variation, I think it should say and passes through 3, 1. What is the equation of the line that passes through 2, 1 and is perpendicular to the first line? So this one sounds a little bit scarier. So we've got a line as direct variation and it passes through 3, 1. So this first part here, if it's direct variation, right, direct, that means it starts at the origin. So we actually know another point on this line is 0, 0. Okay, so we want to know the equation of a line that passes through this point, but it's perpendicular to this first line. So if it's perpendicular to this first line, we're going to need the slope of this first line. So the first thing here, we're going to find our slope, and we have 2 points on this line, right? We have the origin, and we have 3, 1. So we can find the slope using our 2 points. So this is going to be x1, y1, and x2, y2. So 1 minus 0 over 3 minus 0. So our slope is 1/3, but then we want the perpendicular slope is going to be -3. Okay, so next thing we can do is use our slope and our point to find our y-intercept. So we need to find b. So y equals, well, we said our perpendicular slope was -3, and we need this point, this 2, 1, is going to be our point that we're using here. So 3 times 3 is 6, 1 plus 6, so b is 7. And then last we need to write our equation. So y equals, our perpendicular slope was -3, don't forget your x, and then our y-intercept is 7. Okay, so now, get even tougher maybe. So we want to determine the equation of a line that's perpendicular to this one and has the same x-intercept as that one. So since we know we need a perpendicular slope, let's find our slope first. So we're going to find m. And we've got 8x plus 6y minus 2 equals 0. So let's find our slope here. Let's rearrange into y equals mx plus b. Divide everything by 6. So 8 over 6, so it can reduce to 4 over 3. And 2 over 6 can reduce to 1/3. Okay. So then, since we have our slope here, therefore, so our slope is -4 over 3, but we want the perpendicular slope, so that's going to be 3 over 4. Okay. We also know that this new line has to have the same x-intercept as that line. So let's find our x-intercept. So that means y equals 0. So we've got 10x plus y equals 70. So 10x plus 0 equals 70. 10x is 70, divide both by 10, and x is 7. So we know this point, 7, 0, is on our new line. So now we can find our b, right? We have the slope and we have a point. So our slope is 3 over 4, and our point is this x-intercept here. So y is 0, and x is 7. 7 times 3 is 21 over 4. Move that over and we get -21 over 4, which is our y-intercept. And now we can write our equation. So this is y equals, well, our slope was 3 over 4, x, and our y-intercept -21 over 4. Okay. And we've got another example here. So we want to find the equation of a line that has the same x-intercept as this one, and then the same y-intercept as that one. So first, let's get our x-intercept. So we're going to get our x-intercept, which remember, y equals 0. So we've got 4x minus 6y plus 12. This is the one we want the same x-intercept as. So we're going to set y equal to 0. I'm also going to move my 12 over because we know we're going to need to. So 4x equals -12, divide by 4, x is -3. So we know this point, -3, lies on our new line. We also know it has to have the same y-intercept as this line. So let's find our y-intercept. So -5x plus 10y minus 30 equals 0. We can just rearrange and put it in y equals mx plus b form. It's probably easiest. Divide everything by 10. Y equals 5 over 10 is the same as 1/2, and 30 over 10 is 3. So my y-intercept, is 0, 3. And I want to find the equation of this new line that has these two things. So in order to do that, I need to find my slope. And I can do that because I have these 2 points now. So this is going to be my x1, y1, and this is going to be my x2, y2. So I've got 3 minus 0 over 0 minus negative 3. So 3 over 3. So my slope is 1, which is nice and easy. So lastly, I want to write my equation because I have my slope and I have my y-intercept. So my slope is just 1, so just x we can write because we don't need to write the 1. And my y-intercept was 3, so it's just x plus 3. Okay. Alright, so next we're going to try and find the equation of horizontal and vertical lines. So if we remember, when we talked about horizontal and vertical lines, we said the slope of all vertical lines is undefined. Right, because if we remember, we would get a run of 0, so anything that's divided by 0 is undefined. In our horizontal lines, the slope is always 0, right, because the top number is always 0. So if we look at the vertical line, and then we can label the points, so we've got what? 2, 3, 2, 0, and then negative 2, oops, 0, whoops, hold on, 2, negative 2, right? So if we take a look, they all start with a 2. And we have right here, we have an x-intercept, right? This is our x-intercept. On our horizontal line, if we labeled our points, 1, 2, 3, we've got 0, negative 3. Oops, sorry, not 0. What am I saying? Wow, can't write. So x is negative 3, y is 2. On this one, x is 0 and y is 2. And on this last one, x is 2, y is 2. So here, this one is our y-intercept. And if we note, all of them end in a 2. So if we take a look on our vertical line, no matter what the y-coordinate is for the point, the x-coordinate doesn't change. It stays the same. It's 2. Therefore, the equation of this vertical line is x equals 2. The equation for all vertical lines can be written as x equals, and it's some number. X equals a number. If we take a look at our horizontal line, right, no matter what our x-coordinate was, our y-coordinate didn't change. It remains the same. In this case, it was 2. Therefore, the equation of the horizontal line is y equals 2. The equation for all horizontal lines can be written as y equals, and again, it's some number. So y would never appear in an equation for a vertical line, and x would never appear in an equation for a horizontal line. So knowing this, we're going to try one last example here. We want to sketch each of the following lines and then determine the equation of their line. So first we have this horizontal line, and it's passing through negative 6, 3. So again, quick sketch, y, x. X is negative 6, 1, 2, 3, 4, 5, 6, and y is 1, 2, 3. So it's passing through this point right here. So the only way a line could pass through this point, and again, they said a horizontal line, so we have to draw it like this. So if it's a horizontal line, it hits the y-axis, so we know that our equation is going to be y equals, and it passes through at y equals 3. For B, we want a vertical line passing through negative 3, 7. So x is negative 1, 2, 3, and y is 7. 1, 2, 3, 4, 5, 6, 7. So there's my point, and it's a vertical line. So there's my line. And this only passes through the x-axis, so it's x equals, and it passes through x equals 3. Okay, so part C, we want a line that passes through this point. Okay, so let's get our point. the point is -4, -5. So 1, 2, 3, 4, and 1, 2, 3, 4, 5. So there's my point. And it's going to be parallel to x equals 6. So x equals 6. 1, 2, 3, 4, 5, 6. X equals 6 is a point on this line, and the only way for it to be x equals 6 is if it's a vertical line. And we want a line that's passing through that point and parallel to this. So parallel must mean that it is also going to be a vertical line. So in this case, it still has to be x equals, but now it's going to be x equals -4. And my last one here, we want a line that passes through 3, 9 and is perpendicular to y equals -3. Okay, so let's do my point first. So 3, 9, 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9. So there's my dot. And it's perpendicular to y equals -3. So 1, 2, 3. Y equals -3 is a horizontal line. This is my y equals 3. Oh, sorry, this one was x equals 6. So y equals 3 here, but it's perpendicular. So if it's perpendicular, it has to be a vertical line again. So it's going to be a vertical line, and it's going to be through y equals 3, or sorry, x, not y, x equals 3. Okay, and that's the end of this lesson. So try the homework for this. Get okay with horizontal, vertical lines, as well as parallel and perpendicular lines. And if you have any questions,